Cooperate with me as I present the principles and laws of solving equations. In presenting the principles of solving ordinary algebraic equations, I will do so under 8 subheadings, which would also form our content. Please watch the screen to find these objectives. Number 1, operations that do not change the value of a term. Number 2, characteristics of expressed solution to an equation. Number 3, skills of solving ordinary algebraic equations. Number 4, the fundamental law of solving ordinary algebraic equations. Then number 5, applications of the skills of solving ordinary algebraic equations. Then number 6, the precedence formula. Number 7, the general outline of steps of solving ordinary algebraic equations. Then the 8th one, the last one, worked examples and exercises. Now let's turn our attention to the first objective, and that is, as you can see on the screen, operations that do not change the value of a term. There are certain kinds of mathematical operations that, when carried out on a term, will lead to the same number, the same term as the final result. Let us look at some selected operations which, when carried out on a number, the result turns out to be that same number. In this exercise, we are using 5 as a case in point. We're going to carry out some operations on 5, and afterwards we see whether after the operations the answer will still be equal to 5. After we carry out operation on 5, we try to make a conclusion using a variable x, so that the result of what we have done can be summarized by what we will be seeing by means of the x. The first, as you can see on the screen, is the operation on 5. 1 multiplies 5, and the result is equal to 5 here. Therefore, we state that when 1 multiplies 5, the answer is equal to 5. That is to say, it is not just 5, but in this case, 5 is a case in point. Therefore, if x now represents 5, what it means is that 1 times x is equal to x. 1 times x is equal to x. All right, let us look at the second one. Second one is like an accounting, which is the chief cornerstone of modern mathematics. And in this case, we're simply saying plus 5 is equal to 5. I said earlier, not in this topic, that whenever a number is written without a sign in front of it, the sign is plus, meaning having. Therefore, plus 5 is equal to 5. If you just see 5 without a sign in front of it, it actually means plus 5. That is, having 5 is written the same way as 5. Because of that, if we use x to represent the x, to represent the y, if we use x to represent the 5, we conclude therefore that plus x is equal to x. Next, that's number C, is raising 5 to power 1. See it here. This is 5 raised to power 1. This is an operation being carried out on 5. 5 raised to power 1 is equal to 5. What it means is that if we see a number like 5 and there is no power written above it, we should know that the power is 1. Here, 5 is written, no sign. The full nomenclature in terms of power is 5 raised to the power 1. Now, it thinks that 5 raised to the power 1 equals 5. 5 raised to the power 1 is equal to 5. Let's again replace that 5 with x. X in this case is a variable. It thinks that it could be 5, it could be anything else, but it must be a mathematical term. You watch again to see that x to the power 1 is equal to x. It therefore means that when it comes to powers of numbers, if we see x or any other variable and there is no power written above it, it is a short form of writing that variable raised to the power 1. Number D is that of dividing 5 by 1. See it here. 5 divided by 1 is equal to 5. We learned also earlier that whenever 1 divides a number, the result is that number. 5 is not going to be an exception. Here, this 1 is a divisor and this 5 is a dividend. When one person divides 5 things, then the result is just 5. That is 5 divided by y equals 5. Again, as before, if x now represents the 5, we have it that x divided by 1 is equal to x. The fifth operation is adding 0 to a number. In this case, we're adding 0 to 5. Watch it again here. You see 5 plus 0, and that is equal to 5. Logically, we can understand that the answer should be equal to 5. That is, nothing added to something is equal to something. It means there is no increase, there is no decrease. That is, when 5 is added to 0, the result is equal to 5. And see the expression correspondingly, x plus 0 is equal to x. Don't forget that x is just a selected alphabet, a selected variable that could represent all other variables we're going to see in the course of solving equations. If we don't learn these things we are learning right now, it will be practically impossible for us to learn other things that follow. Now let's go on. 2 more operations are remaining. See this one. 5 minus 0 is equal to 5. That is, subtract 0 from 5. The answer will still be equal to 5. Don't forget that 5 here is just a case in point. It could be any other number. That is, 0 subtracted from 5 equals 5. As a result, x minus 0 is equal to x here. Then the last operation is this. The last operation is that of roots of numbers. This is 5. This is a sign of root. This n here means the type of root. If this n is 2, we will be calling it square root of 5. If this n is 3, then we'll be calling it cube root of 5. If this n is 4, we'll be calling it the fourth root of 5. If this n is 5, we'll call it the fifth root of 5, and so on and so forth. So this n represents any type of root at all. That is why we say a certain root, because we don't know the actual one that is playing out here. The reason is that whether it is a square root or a cube root or other higher roots, the principle is the same thing. Please watch out again to see the result of the operation. This is a particular root of 5. When you find a particular root of 5 and raise it to a power that is equal to the degree of that root, the answer is still equal to 5. That is, a certain root of 5 raised to the same degree of power equals the same 5. Which means if it is square root of 5 raised to power 2 is still equal to 5. Cube root of 5 raised to power 3 is still equal to 5. The fourth root of 5 raised to power 4 will still equal to 5. The fifth root of 5 raised to power 5 will still equal to 5, and so on and so forth. That is what you mean by this expression. Because of that, we conclude that the nth root of x raised to power n is equal to x. Don't forget that here we have about 7 different kinds of operations, which when carried out on 5, produced 5 as the answer. Therefore, we also conclude that there exist about 7 different kinds of operations, which when carried out on any term will give that term as the last answer.